Hello everyone. Thank you for joining to listen my presentation today. My study is about use of glucosinolate containing feed such as rapeseed and canola meal as well as its metabolite product allyl isothiocyanate or AITC on the growth performance, gut health and antimicrobial property against Salmonella typhimurium in a challenge model in vivo study. I'm Sudhir Yadav. Okay, so let's talk about Salmonella. Salmonella is the opportunistic gut bacteria of chickens which act as pathogenic bacteria during dysbiosis or increase in its number. This leads to cause increased morbidity and mortality in birds by affecting the major internal organs. It has been reported to cause highest foodborne illness after campylobacteriosis. Chickens and turkey are the major source of salmonellosis outbreak in human. Currently, different salmonella control strategies are being used with some success to mitigate salmonella in farm by use of strict biosecurity measures as shown on the right side of presentation or other dietary inclusions or such as feed additives as organic acid, pre or probiotics, and vaccinating the breeder or broiler flocks as per need basis. Other interventions include in processing units such as use of antimicrobials. Still, salmonella control is challenging due to its being normal flora of intestine. Also, presence of many serotype and its wide host range can persist for longer duration. Lately, also due to discouragement in use of antibiotic due to possibility of developing resistance by these bacteria. So our study focused on the novel way to control Salmonella by use of Brassica species feed ingredient or its bioactive product. Those are known to cause antimicrobial effect. Brassica species belongs to family Brassicaceae and are mostly produced in EU, Canada, and USA. Many studies are done to include rapeseed and canola meal as alternative to soybean meal feeding in animal, whereas its use is limited due to high glucosinolate content. Glucosinolate are the major compound produced exclusively by the Brassicaceae family plants, which is enzymatically hydrolyzed by myrosinase to obtain secondary metabolites isothiocyanate. Different isothiocyanates are produced based on the species of Brassica, of which our interest is allyl isothiocyanate. Glucosinolate could have both negative and positive effect depending on the isothiocyanate formed. Negative effect could be reduced palatability, decreased growth, and interference to iodine availability, whereas positive effect includes increased metabolism, antioxidant, and antimicrobial property, where AITC is known to show beneficial effect, and that is also of our interest in this study. So to test the hypothesis that glucosinolate containing feed and metabolite inclusion will help maintain growth and reduction of Salmonella colonization, we set our objective to find out same in a Salmonella typhimurium challenge model. Different dietary inclusions are two levels of control based on corn soybean based diet with non-challenge and challenge setup, and similarly two levels of rapeseed and canola as well as AITC was used, where lower level of rapeseed and canola are selected based on available literature that shows no negative effect on the growth, whereas higher inclusion is subjected to test for its antimicrobial property as higher level will contain higher glucosinolate. For this, we conducted in vivo experiment for 21 days, where on day 1, birds were orally challenged with 7 log of nalidixic acid resistant Salmonella typhimurium, and microbiology samples were collected on 3, 6, 13, and 20 day post challenge, whereas Weekly growth performance was also considered. For statistical analysis, SAS was used to run one-way ANOVA, where means were separated by Duncan's test, and for mortality and organ translocation data were transformed by root under n plus 1, where n is number of birds considered. For microbiological sample analysis in lab, we collected cecal sample for Salmonella enumeration, and for organ translocation, liver, spleen, kidney, and fecal shedding was checked for Salmonella presence or absence. The fresh samples were enriched in buffer peptone water containing nalidixic acid and homogenized in a stomaking machine. Later, presence-absence samples were kept in 35 degrees Celsius incubator for overnight, whereas Zika was processed on the same day. Cecal colonization of Salmonella was quantified by spread plate method as shown in the figure to get the log CFU per ml of Salmonella colonization. Here is the presence-absence sample processing steps by use of cotton swab to swab on a BGS plate. Now for the result section, based on growth performance result during week 1, the FCR was significantly lower for higher rapeseed, canola, and AITC included group, whereas later in week 2, 30% rapeseed group showed decreased feed intake, and by week 3, the FCR was only significantly lower for 1500 ppm of AITC group. The black box in result section will include the summary for graph in those presentation. During week 3, the body weight gain, body weight and the feed intake were significantly reduced for higher rapeseed inclusion, that is 30% rapeseed inclusion, and canola meal compared to control and AITC group. Higher AITC level showed higher body weight gain than other treatments. Positive control birds had significantly higher mortality, whereas no any mortality was seen for 30% rapeseed, although growth and feed intake was significantly reduced for 30% rapeseed. We also tested intestinal permeability using FITC fluorescence method on day 6 post-challenge, where no any significant differences were observed and value were close to 0, which means there was no increase in permeability, intestinal permeability. For the intestinal histology sample, villus height at duodenum and jejunum was significantly higher for 30% rapeseed, and also the villus height to crib depth ratio tends to be significantly higher for 30% rapeseed as well as 1500 ppm of AITC group. For the cecal colonization of Salmonella, it was significantly reduced for 30% rapeseed on day 6 post-challenge, whereas on day 13 post-challenge, 500 AITC showed significantly lower colonization compared to other treatment. Fecal shedding on day 6 post-challenge showed 30% rapeseed with lower fecal shedding, and also similar pattern was seen for liver and spleen during same time period. The spleen translocation on day 20 post-challenge was significantly reduced for 30% rapeseed again, and for both of the AITC supplementation. Thus, overall summary shows that growth performance was significantly affected by inclusion of rapeseed at 30%, possibly due to higher glucosinolate and erucic acid content, although it shows reduced FCR, which could be due to presence of balanced amino acid, calcium, and available phosphorus. The higher AITC level also improved growth performance, which could be due to selective favor to beneficial bacteria and reducing the pathogenic effect of Salmonella, as well as improved gut histology. Salmonella colonization was reduced by 30% rapeseed meal and both level of AITC, as literature suggests that Brassica species causes increase in bifidobacteria and causes competitive exclusion, whereas AITC are also known to cause bactericidal effect on Salmonella. Thus, as a take-home message, AITC was included for the first time in feed in this study and showed successful result in improving growth, gut health, and reducing Salmonella colonization and translocation. So it mandates the further study using different level of AITC and against different pathogens to see its exact antimicrobial property. Thank you so much for listening to my talk. If you have any question or queries, please contact me in my email, sudhir@uga.edu, or you can scan my LinkedIn and Google Scholar for other papers. Thank you.